Question number 16 asks, in period 3 from left to right, each successive element, and then they ask us about metallic character, number of protons, electronegativity, and atomic mass. Let's pull up the reference table to answer this question. Okay, so here we have the periodic table. Let's pull up the question. Okay, so what we have here is we have period number 3. Here's period 3. Remember, that's a row from left to right. We're asked to evaluate many things. The first thing is electronegativity. Electronegativity is not something you should memorize, but is found on reference table S. To make it simple, I'm going to skip that for right now, and we'll come back to it. The next thing we're asked to look at is atomic mass. Atomic mass is found in the upper left-hand corner of the periodic table. We can see as we're moving across, our atomic masses are increasing. So choice 2 is not appropriate. Now, next we're looked at the number of protons. Recall that the number of protons is the atomic number. That's that bold, very important number found in the lower corner, the left side of each element box. So we do see that we're going from 11, 12, 13. So our number of protons is actually increasing. This is the correct answer. Now, the next part, just to verify that it's not a correct answer, is metallic character. Recall that on the periodic table, the bold staircase is an important geographic marker to delineate the parts of the metals from the nonmetals. And as we move from left to right, here we have metals and here we have nonmetals, we're moving closer to the nonmetals. So the metallic character is actually decreasing from left to right. Now, again, electronegativity can be found and verified on reference table S, but since we have the correct answer, we'll just move on. The next questions have to do with the periodic table. So let's pull up the periodic table so we can refer to it. So the question asks, a solid that is brittle, it lacks luster, and has 6 valence electrons. So if it's brittle and it lacks luster, that tells me it's a nonmetal. And it has 6 valence electrons. So here, valence electrons, the outermost principal energy level, the rightmost number in the electron configuration. The elements here, oxygen, sulfur, selenium, they all have 6 valence electrons. And we notice that these are in group number 16. Next, we're asked to look for a noble gas. Noble gases are found in group number 18. So here we have all of these noble gases. So you can look at reference table S if you're unsure of the names. But here we can see that krypton is a noble gas. Question number 3 asks us about group 17. Group 17 is found on our reference table right here. And we're asked to evaluate their number of valence electrons and their chemical properties. Valence electrons are electrons in the outermost principal energy, or the rightmost number of the electron configuration. Fluorine has 7 valence electrons, as does chlorine, bromine, and iodine. So we have the same number of valence electrons. Now these elements have similar chemical properties. Chemical properties are determined by ionization energy and electronegativity. On table S, we can see that these elements all have different ionization and electronegativities, so they have similar chemical properties. Next, we're asked, how is the periodic table arranged? In what occurs with the atomic radius of group 15. So here's group 15. So here we're looking for atomic radius. On the reference table, we can simply circle the atomic radius of group 15 elements, beginning with nitrogen and phosphorus and arsenic. So when we look at these numbers in order of increasing atomic number, so we see the atomic number going from 7 to 15 to 33. We see that the atomic radius also increases. Question 5 asks about the arrangement of the elements on the periodic table. We're asked to choose between atomic number, atomic radius, mass number, and neutron number. We recall from last unit that mass number is neutrons plus protons. Mass number is not given on the reference table, but if we looked at just mass, we recall that there are some spots, like here, where the mass is not increasing, so the mass is not acceptable. Neutrons are not indicated on the reference table, so that's not an acceptable answer. So we're between atomic radius found on reference table S and atomic number, and we know that atomic number is how the elements are arranged on the periodic table. The next question, we're asked to evaluate an element in period 4 and group 1. So period 4, group 1. So when we look on our reference table, periods are rows. So period 4, group 1, that is potassium. So here we're asked to evaluate potassium. And we are asked to figure out if it's a metal, a nonmetal, or a metalloid. So we know that this stair step here separates the metals from the nonmetals, and anything that's directly bordering the stair step is a metalloid. And then lastly, noble gases are group 18. So noble gas, potassium is not a noble gas. It is indeed a metal because it is to the left of the bold staircase. Question 7, we're asked to look for the element with the highest electrical conductivity. Elements with electrical conductivity tend to be metals, so we're going to use the same geographic location in the bold staircase to find the metals. So we're looking for an element that is to the left of the bold staircase. So that automatically eliminates chlorine, which is here, and helium, which is here. So those are definite nonmetals. Now we're left with hydrogen and magnesium. So here we have hydrogen and here we have magnesium. Recall though, hydrogen is not a metal, it's actually a gas. So magnesium is a metal and will have some electrical conductivity. Question number 8, we're asked to evaluate period number 2. So this is period number 2 from lithium through to neon, and considered from left to right. And we're asked to just explain the periodic trend. So they give us a lot of data about the atomic radius is decreasing and the increasing atomic number, but why? So we're just asked to explain the trend. So we're asked in terms of protons. Remember that protons are the same thing as the atomic number. So we can see here that the protons, the atomic number is increasing. So that will eliminate choice 3 and choice 4. Next, we're asked to look at the number of shells of electrons. So here we can see lithium has 2 shells, beryllium has 2, boron has 2, carbon has 2, and so forth. So the number of shells are the number of numbers listed and the electron configuration. Question number 9 asks us which list of elements is listed with increasing atomic radius. Now you could memorize the trends for atomic radius, though I don't recommend it. Simply use reference table S. So again, we're looking for increasing atomic radius, and we're going to begin with lithium, beryllium, boron, and carbon. So lithium is number 3. So as we look here, 130, 99, 84, those are decreasing atomic radii. So number 1 is not the choice. Next we have Scandinavium, titanium, vanadium, and chromium. So we can see these elements are listed right here. And here we can see that the atomic radius of these elements is again decreasing. So that's not the appropriate choice. Next we have strontium, calcium, magnesium, and beryllium. So here you can see calcium is number 20. Where is number? Calcium is number 20, which has an atomic radius of 174, and then magnesium, which is number 12, has the atomic radius of 140, and then beryllium, which is number 4, has 90. So this is decreasing also. So next we're asked to look fluorine, chlorine, bromine, and iodine. So fluorine is number 9, and fluorine has atomic radius of 60, and chlorine number 17 has the atomic radius of 100, and then bromine number 35 has the atomic radius of 117, so 60, 100, 117, those are increasing, so this is the best choice. Question number 10 asks us which atoms on the periodic table have the stable outer electron configuration, and remember that that represents the noble gases, and the noble gases are found over here in group number 18. The next question asks us in which of these atoms is the ground state can the valence electron be removed with the least amount of energy. So electron to be removed, this is the ionization energy, and then this is least. So we're looking for the smallest ionization energy. So we should look at reference table S. So looking at reference table S, we're going to look up the first ionization energy, and we'll simply place a mark by the elements as we look them up. So we're looking at nitrogen element number 7, which has this ionization energy of 1400. So here we go. And then we're looking at oxygen element number 8, carbon element number 6, and chlorine element number 17. We're looking for the smallest number. And so here you can notice that carbon has the smallest ionization energy of all of these choices. Question 12, we're looking for two metalloids. Recall that the metalloids will border by two sides the bold staircase of the periodic table. So our choices include boron, which is not listed here, silicone, which is listed. So here I see there's a silicone here, I see there's a silicone here. Then after that we could have germanium, so I see there's germanium here. We could also have arsenic, so here is an arsenic here. We could also have antimony, which is Sb, so we have antimony here, and tellurium. So here we have choice number 1 has 2 metalloids. The next question asks us to evaluate nonmetals. So keyword here is nonmetals, and we're asked to look at their electrical conductivity and their ionization energy. Ionization energy is found on reference table S. We'll look at that shortly, but with electrical conductivity, nonmetals are poor conductors of electricity, so they could not be choice 2 or 4 because those represent good conductors. So we need to evaluate the ionization energy of nonmetals using reference table S to see if it is high or low. So now we just need to find some metals and some nonmetals on the reference table and evaluate their ionization energy. So what we can do is we can just look across, let's say, period 2, which begins with lithium. Lithium is a metal. And so we see that lithium and beryllium are metals, And when we look at their ionization energies here, we can see that we have 500 and 900. And if we go in the same period and we look more at like nitrogen, oxygen, and fluorine, we can see that their ionization energies, which are listed over here, are much higher. So in general, nonmetals have high first ionization energies. Next, what we're asked to do is find a noble gas at STP. So recall that the noble gases are group 18, so we're just finding an element here in group 18, and neon is a noble gas. Question number 15, we're asked which atoms have the greatest, that's important, and then tendency to attract electrons, that is electronegativity, that is the definition of that. So we're looking for the highest electronegativity. So for this, we are going to refer to reference table S. So on reference table S, we're simply going to look up the electronegativities. I will circle them in red. So here we have a red dot by the electronegativities of all of these substances, and you can see that bromine has the highest electronegativity. In question number 16, what we're looking for is the greatest metallic character. Recall again that the staircase separates the metals from the nonmetals. Now when we look at our choices here, we have all nonmetals. We have nitrogen, antimony, phosphorus, and bismuth. So here we have nitrogen, antimony, phosphorus, and bismuth. So these are all in the same group, and we're looking for the ones that are most metallic. Now nitrogen is a nonmetal, as is phosphorus. Antimony is a metalloid, and bismuth is actually underneath the staircase. Bismuth is a metal, so bismuth is the best choice here. Next, we're asked to look at group number 17, and we're asked to look at the chemical reactivity. So when I look at group number 17, which is here, I can see that the majority of the elements are nonmetals, and we can recall that nonmetals tend to gain electrons. So they tend to gain electrons, and species that gain electrons the best are species that have the highest electronegativity. So what we'll want to do is we'll want to go and see how the electronegativity changes as we go down the group. As we look up electronegativity on the periodic table, we see fluorine is actually the most electronegative atom. Since fluorine has the highest electronegativity, as we go down the group, we get lower electronegativities. Our chemical reactivity actually decreases. The next question asks us to look across period 2 from lithium through to neon, and notice we're evaluating atomic numbers, atomic radii, ionization energy, and electronegativity. All of these values are found on reference table S. So here we're looking at period 2, we're looking at the metals and the nonmetals. So here we have metals, here we have nonmetals, and we're asked to evaluate what features the metals have that are greater than the nonmetals. So when we look down here, we see that the metals have a lower atomic number than the nonmetals. Now when we look at the ionization energies, we will see that the metals tend to have lower ionization energies than the nonmetals, so that is not the correct choice. Now we'll look at electronegativity. So the metal electronegativities is smaller than the nonmetal electronegativity, and so we're left with atomic radius. So when we look at the atomic radii, we see that the metals here have much larger atomic radii than the nonmetals. So atomic radii is our best choice. In question number 19, we're asked to look at group 2 elements, and we're looking for the lowest first ionization energy. So this is group 2, and this, we're looking for the lowest first ionization energy. So again, we're going to look at reference table S. Here we're simply looking at ionization energy for these elements. So with the first ionization energy of 503, beryllium has the lowest first ionization energy. The next question asks us to evaluate the similarity between arsenic and silicon. Now, first they ask us to look up the ionization energy, and we see that their ionization energies are different, and as are their atomic radius. Their atomic radius is found here. So now we have to evaluate, are they metals, transition metals, or metalloids? So we are looking at silicon and arsenic. And we know that silicon and arsenic found on the bold staircase are both metalloids. So metalloids is the best answer here. Question number 21 asks us to evaluate the trends for period number 3 as we move from left to right. So this is period number 3. And we're asked to judge the metallic character and the electronegativity. Recall that the bold staircase separates the metals from the nonmetals. So as we go across, we have metals with sodium and magnesium, and then we have nonmetals over here. So the metallic character is decreasing. And now we need to evaluate what is happening with the electronegativity. So we can evaluate electronegativity using reference table S. Notice on reference table S, here are the period 3 elements, and the electronegativities are listed. We'll see that there is a general increase in electronegativity. For question number 22, we're asked to look at elements in the same period or row of the periodic table. And as we look across the row, what we'll notice is that they change in a very systematic manner. So the periodic table is called periodic because there's a period or a system in which it is arranged. So choice 3 is our best choice. Finally, question number 23, we're asked to evaluate the properties of metals. Now, metals, we know, tend to be ductile, meaning you can pull them into wires, and they're not brittle like nonmetals. So we know they're ductile, and we have to evaluate their ionization energy. Their ionization energy can be evaluated on reference table S. Now, looking at reference table S. So looking at reference table S, if we pick, let's say, period number 2, starting with lithium, moving on over to neon, when we look at period 2 and we look at the ionization energies, the metals like lithium and beryllium tend to have lower ionization energies than fluorine and oxygen. So they tend to have low ionization energies. So they are ductile with low ionization energies. This concludes the review for your periodic table exam.